Okay, good morning. So I want to talk about NEDs and NetSim. What are NEDs? Why are they? And what's so hard about them? Again, we can try to make this interactive. So if you have any questions or comments, raise your hand, and if I see you, I'll try to get you in here. We have some of the real NED developer folks here in the corner. You can stand up so everybody can see you. Applause, yes, please. The team is actually as large as this room probably, so they're not all here. But we had a few experts in here, so that any questions that are really hard can be answered by them. No, they are all secret agents, so we'll not name any. Okay, I want to talk a little bit about what the framework around NSO, NSO, what it is, and the network OS and the API that it is, and how NEDs play into that context. And then have a look at the role and economy of NEDs. Because this is, if you want to really understand NEDs deep down, you have to understand even the economy around them. Every NED is living up to a certain contract. It has a function to fulfill, and I want to explain what is it that we expect out of a NED. NEDs, one of the things they do, they implement transactions on, well, sometimes the devices are transactional, but many times they are not. So how did that happen? And then talk a little bit about NetSim, what it is, how you can use it. And then, as time permits, talk a little bit about troubleshooting at the end. We'll see. So first, NSO, it's all about the API. I mean, we talked about that yesterday. NSO is an API to the network. And so the network API, that's really what NSO is about. And if you start with this block diagram picture, you can see you have this service manager, you have the device manager, you have the database, you have packages, but somewhere on the bottom you have the NEDs, the pieces that allows NSO to talk to anything. As I said, something like yesterday, NEDs are the ones that make it possible to talk to physical equipment or virtual equipment. You can talk to things that are locally here in the data center or somewhere remote out in customer premises or even at homes. It can be layer 1, 2, 3, 4, 5, 7. It can be, what else? It can, of course, be different vendors. And it can be different roles in the network. It can be firewalls or routers or something entirely different, a piece of software, a server, OpenStack. What else? Something else that you've just written. So all of these things is what the NED needs to plug into. Whatever it is, any protocol, it can be SNMP, netconf, CLI, some sort of home-cooked REST from some vendor. So that's all everything that we demand of an NED. It should be able to talk to anything, really. When we talk about NSO, we're really focusing on the service manager and device manager. That is the public API that we publish to you, that are writing applications. And the NEDs are the foundations below that. It's just, you count on it being there. But it's somebody's hard work to make that happen. We often talk about NSO being model-driven. We have the service models, we have the device models, and the device models, where did they come from? They come from the NEDs. These are the models that are exposed by each NED. What NSO provides is a programming environment, so you can write applications, very much like an operating system. You can take any operating system, it provides a framework for you to plug in whatever functionality that you need on top of that. Either you write it yourself, or you grab some open source, or you might even be able to buy applications off the shelf. But really, it's about being able to run those applications. So it's very important for us to have a nice and stable and very easy to use programming environment. That's really what NSO is about. Make this environment, make it easy for you as customers or as developers to develop applications. And in order to make these applications easy to write, we require that the application framework here, NSO, should provide a transactional, model-driven, real-time, network-wide, multi-vendor, cross-domain, and physical virtual agnostic API to the network. Your applications should ideally not have to deal with this because the platform will take care of that. And a large part of taking care of that falls on the NEDs. If you look at the device manager, it provides this API. You can touch anything anywhere in the network. Since it's transactional, it's offloading a lot of the error handling. And if you look at the traditional NMS, it will have a lot of code. Usually something like half the code is for detecting and recovering from error situations in a mature NMS application. So this is a lot of code. By having this transactional guarantee in the API, we gain a lot of flexibility and reduction of code in the application layer, which is where you come in, right? You want that. It's fundamentally important that you can get transactions out of the platform, no matter what is below. But it adds to the complexity of the NEDs, because they will have to provide these transactional guarantees to you. I will not spend too much time on this with Service Manager, but really, you can see you're building a stack of applications on top of each other on the NSO platform. And in order to be able to build this stack, again, we just come back to this API. It has to have these properties. It has to be transactional. It has to be model-driven and all these things. And it all comes back to this vision that the SDN movement got back in 2010 and 11. And this is a slide from the SDN founders, where they saw, well, we need something called a network operating system, and then we write applications on top of that, and we can even have service applications that are working on a more abstract layer on top of that. In this vision, network operating system needs to have an API that goes from one single abstract API to everything in the network. And it needs to be logically centralized, transactional, and have a global device view. That is just to set the context of where we find NEDs. So if you take a little bit closer look at the NED layer, really what it does, it's providing the rest of the system with a view that the network is a distributed database. With a transactional API then. And if you dig down, you can see devices are very different. Some are pretty capable. We have netconf capable, usually, it's what I put on the left side. Transactional devices, they have a lot of support, and they have a good API already. And what the NED needs to do in that case is merely to represent the model, the Yang model of what you can do with those devices. Everything you can configure, everything you can monitor, all the administrative actions and the notifications that this device can generate is explained to the rest of the system in the form of a Yang model. And this Yang model needs to be extracted from the device in some way and then loaded into NSO. And that is this little piece of NED up here. Something needs to happen. We need to extract that model, compile it in some way so that NSO can interpret it. And that is what we do for NED in that case. If you have a capable device with good APIs, but not quite transactional maybe, you have a little bit bigger NED. It has to fulfill the gap up to the level, right? If you have a simpler device still, the NED has to do even more. And if you have some of those really horrible devices here with some home-cooked REST API with no regularity, because all these APIs have been added over years, they all behave differently, they overlap. There's one thing to set, but there's no call to actually read what you just, I mean, it gets very messy sometimes here, horribly messy. And then the NED has to do a lot of work to bring up things to this transactional API level. Does it make sense? Come on. Yes. And one more time. Yes. Thank you. So we can split the NSO system into the upper and the lower half, we like. Where the upper half is in the nice and clean world of transactional APIs, and the lower half is in the gory stuff. Just think of a city. These are the nice skyscrapers sticking up there with very flashy bank brand names at the top. And here's the metro system and some other systems that you just depend upon, all the electrical cables and other things that go in the ground. That just makes everything else possible. So the NEDs come in different flavors, right? We have different protocols, so we divide them up by group here. We have netconf NEDs. We have CLI NEDs, which is the vast majority. We have some, at least in theory, some SNMP NEDs, but they are very few. And we have the other group, which we sometimes call the generic NEDs, which are anything else. And they sometimes fairly small and simple, but often very complicated and expensive. You can see here, on the side here, you have this, what does the NED consist of for one of these? It consists of downloaded device models. For Juniper or Cisco IOS XR, NSO can just connect to these things, download the Yang models, compile them, and off you go. Actually, for the Junipers, it's not completely true, but in principle, they're close. They are getting there. For Cisco XR, that actually works, XE as well. Many other devices out there that are using confd built in, this will work just nicely, and a few others too, actually. I'm going to those EANTIC netconf Yang interrupt tests every year, and there's a few more every year that actually can do some of these basic things here. So things are getting very simple here. For the CLI NEDs, the NED consists of, well, you have a device model that describes everything you can configure, monitor, execute, and get notifications from it. But you also need a piece of code, Java code in this case. What is this Java code doing? We'll talk a lot more about it. But it's not understanding the model. The model is describing everything you can configure and monitor. This one is only doing things, simple things like, oh, I need to be able to log into the CLI and navigate the subtree structure of that. I need to recognize if this command was OK or if it failed. Is this an error message or not? Things like that. That's what the Java code, in principle, is doing. Then we have these guys, the generic NEDs or the other. It also has a Yang model, and then a larger chunk of Java code. Yes?
Is it possible to have a NED that is part netconf for certain aspects and CLI for the rest?
Is it possible to have a NED that is part netconf and part something else? For different tasks, it is in theory possible. You could have a NED where you're doing the configuration over netconf but reading over CLI or something like that. That would kind of work. But if you're trying to configure something transactionally over two channels in parallel, that is really pushing the limits of what transactions can do. You cannot really get something to happen atomically across two different channels. Commit at the CLI and commit at netconf happening together, so they always both succeed or both fail. Things like that would be difficult. So in practice, no. But for different tasks, as I said, it is possible, for example, to read over an MP and configure over netconf and stuff. That is even configurable in NSO directly. But it's a rare case. Any other comments or questions right here? So let's look at the economy around this then. Since we are downloading Yang models directly from the device in the netconf case, and there's no Java code or anything like that, the economy is pretty good. Let's say in the Junos device, it has something like 200,000 leaves that you can set or read. We wrote exactly 0 lines of code for that, so the economy is pretty good. 0 for 200,000, good deal. The iOS XR, this number, 24,000, is a little old. The latest version, this is constantly growing because the support of our netconf in XR is not for everything, but they are trying to expand and expand and expand, so more and more leaves are being added. This is probably a year old or something. At that time, there was support for 24,000 leaves over netconf on an iOS XR device. Again, we don't have to write any code for that, so this is still a pretty good deal. 0 work for 24,000 lines of, or 24,000 leaves that you support. For the CLI devices, we have the heroes here. They are writing Yang models by hand, trying to mimic whatever you can do in the CLI by writing things in the Yang model. And not only writing the names of these leaves and the values they can take on, but also saying things like, oh, this particular name of this leaf is hidden, and when you present it, these 3 things will go in a single line. And if you type this command in and that command, you need to say this one first before you do that one. All sorts of this, well, the CCIE training stuff. Every CCIE, they will be trained on this so much, they will never be able to even conceive of a configuration where you type this other command before the first one. I mean, they will not even be able to think that thought. But computers are not that smart. They haven't taken the training, so they don't know about these rules. So we have to tell them in forms of annotations in the Yang file. So that's why you say here, it's a handwritten Yang with annotations. Writing the Yang files to get all the elements in there is probably not that difficult. It's a lot of work, of course, if you have to write 24,000 of them, but it's not so difficult. But getting those annotations about the specific behavior right, that requires a lot of experience. That's why we are not asking you to write NEDs in general. You can, we cannot stop you from writing a NED. You can just do NCS make package and you have a NED if you like, and you can start developing that. But experience tells us over the years that it's better to have the NED team do the CLI NEDs because they know these annotations and how you write this in a way that is forward compatible. That is really why we want to keep the NEDs to ourselves, to save our support department from additional work. Anyway, so there's some Java code in the CLI NEDs, but it's not, I mean, this Java code, as I said, is about logging in, about navigating submodes, it's about persisting the configuration, it's about recognizing error messages. So there's not a direct connection between each Java line and anything in the model. So the number of lines here do not exactly correlate with the number of leaves. It's about which tasks that you can perform and how complicated it is to recognize an error message that constitutes these lines. But still, we have to write for the iOS NED 4,700 lines of Java to do all those things. And we had the Yang model with 5,500 leaves. So that gives us a cost about 0.85 lines of code per leaf. Of course, if you want to expand these 5,500 to cover more and more as we want over time, probably this economy will get a little bit better because I expect we will add less Java code than leaves. But it's still rather more costly than the netconf side. And the iOS is still something that is fairly nice and regular. For some other operating systems, like this is the FTOS, what's that? Say again? Dell device. Then, since it has so low number of leaves that we support, this ratio between the lines of codes and the leaves becomes much more expensive. So 3.4 lines of code per leaf. Yes?
Is one of the limitations of using the netconf for legacy devices that are normally CLI net based is that if there's one single leaf that you absolutely need to have, and it's not in the Yang model yet in the netconf support
Yes.
for the device, then you've got to go back to the CLI net. Where it looks as though you've already pushed out, because I'm using an XR net and iOS net that are CLI based still, because I'm using the older version of NSO. When did you cut over to a netconf XR net?
We haven't. They exist in parallel. But in the so the question is, when did we move over from XR being netconf? No, we haven't officially moved over anything. Is anybody that's interested to use netconf on an XR can build their own netconf NED and use that instead of the one that's shipping with NSO. Yeah, I mean, there are tools, and I can show you how to do that if you like. And I think there's even a slide at the end about how you build your own netconf NED. But we are not pushing anybody to go to this side just yet. Because there are, I mean, as you say, the coverage over here, the 24,000 leaves may sound like a lot, but it's quite often just one or two that is still missing here that you need. So people don't want to go here because they want to stay here with much more leaves covered, or at least if something is missing, they will just tell the NED team to say, can you please add those two, please? And they can do that. Whereas the team you need to tell something here, if it's missing, is the XR team. And the XR team may not be able to crank out that feature in 2 weeks. Another thing is that some of these leaves, they exist in the model, but they don't work properly. This is kind of new, so of course there's some. Yeah.
That's the whole point, though, is that if it's in the CLI net, then you can manually, and I do this all the time, I go in and I'll change the, enhance CLI net. But if it's not in the Cisco device netconf support, it's an actual firmware revision update.
That's right. Actually, it is in XE, for example, it's not firmware. It's the netconf support there is one of those add-on container, whatever, plug-in device, plug-in things. So that's something that you don't need to change the router firmware for that. You just install a new version of this plug-in thing.
So it's a patch, basically.
It's not. It's a. They have, I forget what they call it. It's a plugin system. You can install applications on top of it, and the netconf support is one such application.
So from what I heard, ISXR 6.1.x, which is quite new, should be fully 6.2.
Yeah, I have tried netconf on 6.1, and I wouldn't recommend anybody to do that. But 6.2, then things are starting to work. People have been using netconf on XR for a long time already, several years, for specific use cases that Cisco made work, that works. So sometimes, some use cases you can definitely make work over netconf today. And the number of use cases is growing all the time. But it's, if you take a random use case that you're working with here, you will probably hit something if you move over here right now. Maybe not unfixable or something that you can't live with, but there will be some issues, quite likely.
The number of leads between CLI and netconf are different, like 2 orders of magnitude. What's the reason behind that?
Because these are the leaves that are published by the device, raw. Everything is in. These are leaves that somebody asked for in the real world. So these NEDs are developed by demand by customers. We have a use case. We need these things. And only things that somebody ever asked for are being modeled. And of course, most people aren't, everybody knows this. We are just using the 10% of everything that's available. If everybody was using the same 10%, that would be nice, but it isn't. It is this 10% and those 10%, and of course there's a great overlap, but not all the corners are being used. So that's why we see 5,500 is actually enough to support a wide variety of use cases on iOS. All our customers today are using these 5,500, and they're fine with that. So we don't need a 24,000 really. If you could just make sure that those 5,500 are supported in the 24,000 here, we were pretty good. But there's not a total overlap there. Any other comments or questions? So I'll move over to the other column. Here, these lines of code correspond very much to being able to understand how to fetch this particular value from the device. So these numbers of lines of Java, they grow together with the number of leaves. And it's, as you can see, it's typically more than one line of code for every leaf. It's, for the NetScaler, it's 4.3 lines of code, and for this VXOA, it's whopping 7.6 lines of Java for every leaf. That is expensive. You don't want to spend too much time there. And you can also see the number of leaves supported gets very low, because do you really, really, really need one more here because it's so expensive? People are being pushed back. We only want to support the bare minimum on these devices. It's very expensive to develop and maintain that. And also, I would make myself ridiculous here on the stage if I try to explain how much I hate those APIs. They are just so crappy. I don't know. I mean, if somebody tried to make an evil interface, it wouldn't be worse than those anyway. People think that, oh, it's nice and modern, cool REST APIs. And you can make very nice REST APIs, but people don't. Almost every time I see a REST API, I will regret hearing about the name of that device. People designing those REST APIs are not, they have never tried to be a customer to really use those. They might make nice examples that for this particular use case, you just make these 17 calls, but we want something that is model-driven, and these are very seldom anything like model-driven. So you have to write a lot of lines of code for everything you want to touch. There's no regularity that you can compute beforehand. Oh, this is what it's going to look like for all these calls. Modifying this parameter like this, it's going to be like this. You have to have individual lines of Java code for everything, everywhere. So if you want to go to the nice and beautiful world of the future, clearly I see an arrow pointing in this direction. It's not the perfect world yet, Many people are here, at least for some devices in the network. It actually works for them for some use cases, but it is the future. As we develop network management, that's where we need to go. Any comments or questions, or anybody dare to disagree?
Do you see any easy, or what do you see as the eventual solution for getting SNMP, with all its insecurities and limitations of configuration, out of the OSS space?
I mean, I see SNMP being used a lot, but only for monitoring. And I don't care that much about monitoring. I mean, that's an easy thing. To poll some variables, you can do that in a number of different formats. There's no rocket science there. Maybe hard work, but no rocket science. So for configuration, SNMP is dead since a long time back. I mean, there are a few diehards out there that are actually configuring something over SNMP, but it is a rare event. We don't care. We can just ignore that.
Well, the problem is that something that my group's done a lot of is having to implement the status side, like BGP status collection and then the processing to make it, to present it up by VRF and by customer.
Yes. I mean,
It would be more helpful if there was more of a priority spent on getting the status in a formatted way out of the devices.
yes. Netconf is actually pretty good at that. So if you build this properly, it will be there. And actually, I know that a lot of effort inside Cisco, at least, is happening on that front, providing Netconf support for all that status data.
Irene, you said that we can forget about SNMP. We have a customer who
Configuration on SNMP, yes.
configuration that they have a satellite modem which uses SNMP.
Mm.
So there is the fourth category, and it was actually rather easy to create a net for it.
Yeah. I mean, you get a NED that is sort of working on SNMP level, which is
The MIB is good.
yeah. I mean, if the MIB is good, you can do that. And the problem is that they seldom are, and you get a model that is feeling awkward to use from your applications. But
So you're saying you were lucky.
yeah, essentially, I think so. I mean, I've seen many cases where people try to do something with SNMP. The quality of SNMP MIBs out there, I mean, generally, they don't even compile in the first run. So anyway, I think we can mostly leave SNMP aside in this discussion. Okay, so I already said this, but basically, you can work with those different kinds of APIs, CLI, SNMP, homegrown REST, and whatever it is. But in the long term, we have to go netconf because we are spending a lot of time and money on this translation step to those other technologies, which gives us zero benefit. I mean, it may be nice for an operator to sit in the CLI, but seen as a management interface for machine to machine, it's just stupid. It's not the way to do things as an engineer. What I want to do is something like this. Okay, I go in NSO and I say, device is device, this new thing, here's the address. I say it's a netconf device. I can ping it, okay, nice, and then commit. And then, okay, I know about the device now in NSO, but I can't talk to it because I have no idea about its capabilities. But what I want to do is then run the command, download, build, install netconf ned. Okay, wait a few minutes, and sync from, and suddenly I have read all the config from the device and I can manage it immediately. And I've done this. It took me 120 seconds with one of the devices. I went into a lab with a, for me, unknown device. They told me the IP address and the credentials. And I did these things, and I had a sync from. I could manage it within 120 seconds. That is sort of scale that I'm looking for. That is not happening with CLI NEDs, because even if the NED team is very fast, they haven't made a 120-second record yet.
Which device was it?
It was an Elastic Services Controller, ESC.
That's the only one, I guess, that can...
No, actually, there's quite a bunch, because all the Conf devices out there can do this if you connect to them like this. Not all of them, but most of them. Most of the people that know how to use Conf, it's not no work necessarily, you just need to configure it properly.
That's not Juniper, right?
No, actually, Juniper is pretty close, but they have some issues of their own. And last Antic in February, they were excusing themselves. Yeah, we're getting, there's some technicalities inside our solution, but we are getting there. So I think it's pretty close for them too.
What version of NSO were you using that had this command?
I kind of I was using the Pioneer package, so there's no command called just like that in Pioneer, but it would take 3 screens to say all the commands I did, but it did take 120 seconds. And basically the commands I used were download, and build, and install, and okay, so. There is something called the NSO Interop Lab. It's a service that Cisco provides to mostly anybody. We haven't seen an application from Huawei just yet, but maybe that will come one day. But to anybody in the industry that has sort of system or device or server or something that they would like to see and verify that it works together with NSO. So we invite everybody, and you should know about this so that you can mention this when the right moment appears in a customer situation, perhaps. If somebody says, you're together with a customer in some location, and this other representative from this other company says, no, I mean, we haven't verified that NetConf really works together with NSO yet. Oh, but there's this NSO Interop Lab. You can join there, and we can verify that, or we can help you verify that. And what it is NSO running in the cloud, in the cloud specifically. So we create a dcloud instance for this third-party vendor with NSO running in it, but they don't get root access to this device. They only get the CLI access to then running NSO, where they get Pioneer installed so they can do this download Yang models and compile them and see how many syntax errors they have in the Yangs and whatever else. And then they can run tests from NSO, like go to NSO, configure this, configure that on my device. Commit, does it work? Can I read? Can I use XPath filters? So they can log in there. We don't see what they have in their lab. So they can have all sorts of new technology that they don't want to share with Cisco. They don't get any more access to NSO than the CLI. We don't know what they are actually testing or what the results are. So this is a setup that I think has so far been quite accepted by most vendors, even those that are, well, on paper at least, quite fierce competitors of Cisco. They are happy with this solution. It allows them to be able to stand in front of a customer, a joint customer that is using both Cisco and this other vendor, and say that, yeah, we have tested this. It actually works with NSO 441 or whatever. And if the customer reports, well, it doesn't in this use case, they can go back in the lab and test just that. That make sense? Is there anybody we should not invite to this, or should we invite everybody? Everybody. Good. So this is the slide that we give to participants. I mean, we give a whole pack of stuff, but the last slide in the presentation that we give to the NSO Interop Lab users is, okay, you connect to the lab, then you download the Yang models to NSO, either directly from the device or using SFTP if you don't support the download feature. You check the dependencies to see that you actually have a complete set of Yang models. Very often there are a few Yang models missing, so you can't compile because they are not there. Then you compile these things and fix anything that's wrong with it. And very often this takes some time because there is usually a lot of things wrong in Yang modules that other vendors supply to the world. I would say it's more common than not that something is wrong with them. Then you install the final NED when you got it to load, and reload packages and sync from. And then you can start to try it out. For example, can I show the configuration? Can I show these stats counters and whatever? Can I receive notifications? And then you go off and collect a number of different configurations that you are using together with your customer. Oh, they're using this and they're using that. And then load those configurations into the system. And then there is a feature in the Pioneer package which can try to move from one configuration to the other, to the first, or whatever, in any combination, because that should be possible in NetConf. And then they will detect some of those transactionality issues that they might have in the device. So that's the idea with this NSO Interop Lab. Any other comments, questions? Yes? Oh, you just shout loudly.
But is Pioneer available?
It is available, yes.
Not in just the running instance, but if I want it, can I just run this?
If you have access to the NSO package library, you'll find it there. If you don't, send me a mail and I'll get it to you.
Okay.
Yes, you can find it on DevNet. I'm not sure everybody would have access to it, but if you don't, get to me and I'll make sure you get a copy.
Just pointing it to operational, like RPC commands, can it work out? So I've used Pioneer to create a NED for config level stuff, but all the operational questions, like basically show commands, but programmatically.
Well, and Pioneer has no idea about those things. It only downloads and builds the model, and if there's no operational stuff in the model, sorry, Pioneer cannot do anything about that. It will do everything that's in the Yang. Okay, so what does NED really do then? What's the NED contract? What is that we expect of every NED? Every NED needs to provide a Yang model, because the Yang model describes everything you can configure, monitor, actions, and notifications that you can get from this device. It needs to support a number of API callback functions, and I will go through them with you shortly, just to give you an idea. It may also have support for NED upgrades. The NED team says that this actually rarely needed, but okay, some of them have it and have had it in the history. If you have a device that supports HA, so that you have two devices acting as one, and you have an automatic switchover mechanism and all of that replication of config and stuff, there may be some need to have support for that in the NED as well. Of course, they support Netsim. In most cases, that is really easy. You don't have to do much at all. But technically speaking, the NEDs are responsible for making sure that Netsim can work with this stuff. And there's, of course, some documentation to some degree, but not a user manual for the NED. It's just this documentation is mostly saying how you build it. I'll come back to that. So you need to provide a Yang model for the device. And the Yang model, in the nice case, you can just download it from the device. But that's pretty much only netconf devices that can do that, right? For other device types, we need to handcraft this Yang. There is, of course, very tempting to generate a Yang model from some other source, from some C code, for example, or some other sort of modeling language that the device might support. We are doing this for Juniper. So today they are releasing an XML schema representation of everything you can do with the device, and we are successfully using that to generate Yang models. But that is more or less the only successful use case. We have tried this together with other teams and customers many times, and the quality of the resulting Yang when we try this has always been, well, beyond hope. So we're mostly recommending people not to try because it's a waste of time. But if you really want to do this, I'm one of those, compilers kind of guys. I like translating from one format to another and stuff like this. Happy to work with you on that. And NED also needs to support a number of callbacks. I will get into those in a minute. And then it needs to translate the gist of that callback into something that goes over the wire to the device. For example, in the form of CLI commands or REST or SOAP or something like this. For netconf NEDs, there's no need to do anything because it just follows the netconf protocol. Sometimes when we have new versions of a NED, the new version of the NED is incompatible in a way with the old version, so it needs to upgrade the data in some way from the old NED to the new format. Most of the time, it's enough to just do a sync from with the device instead. To read, you install a new NED, you do a sync from, and you're populated with the new data. But there are some cases where that is not good enough, so then we have had upgrade clients. Let's not go into the technical details of this, but it happens that you have to do this, even though it's rare.
I have a question.
Yes?
So when you have services, you save the undo data, right?
Yeah.
Which is like a diff set.
Yes.
That works towards the Yang model, provided by the NED.
Mm-hmm. Yes.
So when you upgrade the NED and the Yang model has changed, what happens to the undo?
Yeah, if you're unlucky, that will fail.
Right. So this has failed a number of times for me.
Yes.
So is there any plan to do anything about that?
It comes back to the NAD economy. I mean, if we want to support a large number of devices with a lot of features inside, We will have a much larger NED team if we also wanted to have backwards compatibility and all of those things. So I think in reality, for economic reasons, the answer is sorry.
Okay, I'm not sure that that was actually the answer I was looking for. So, I mean,
No, but
well, I mean, what happens for me is that it breaks, right? I can't delete the service because NCS tries to do something that's no longer possible.
mm,
So, I mean, I'd call it a bug. I'm not sure if I'm actually calling it like, I don't know, necessarily magically work out in the config or something, but it's just the undo patch will just break.
yeah. Yeah, but I mean, you are definitely pointing to a sore point at NSO. Replacing packages that are modifying the Yang model and some things like that break, definitely. And we should probably collect those use cases and make sure we solve them, but not in the NED, but in NSO.
Right.
Because,
No, I agree with
yes.
that. But also given the multi-version NED support that's just coming out, I mean, I see definite improvements happening.
Yeah, exactly.
It also be something that goes kind of hand in hand.
Yes, but to add substantial amounts of new requirements on the NEDs that already have a pretty long list, that won't scale economically very much. So that's why this sort of functionality would have to go into NSO. But yes, I agree, it's not a good thing with NSO that if you have services that we're using in old NED and the NED changes significantly, then things might break. You can always get around this with, if you call the support, they will tell you sequences of commands that we need to do to resolve the situation, at least clean it up, but it's not ideal. But the list of requirements for NEDs is already long, so we don't want to add a lot of more. You need to do it better, you need to do additional functionality for every NED, because that will slow down the NED development. But it is a trade-off. Good point, though. Any other comments or questions around NEDs at this point?
Probably one thing to follow up that sort of thinking, right? Particularly with the operational data, like something that's very expensive is certification and testing for devices. So pumping it through IT, checking all the OIDs, SNMP will still responds, is all really expensive. When we get to the netcom utopia, you can just, every time you upgrade software, you just dip the models. If they're the same, it's going to work. And it's a text file, right? You can just dip the model and see if all of those values are still there. So a lot of that tax goes away. So that's why we kind of have to fight for the green box, right? The utopia is a good place to go.
I'm not religious, but amen to that. Okay, some devices, they have support for high availability, meaning two devices that are replicating configuration between each other, and they should essentially be treated like one device in most aspects, but there are certain details, for example, the HA setup that needs to be configured differently for each one. So then the NED needs to know that this device can sometimes have two management IP addresses, but you should treat it still as one. And you only send the config update to one of them because they will automatically replicate whatever it's internally and stuff like that. So there is some work to support HA in the NEDs as well. We have NetSim. NetSim is this tool that allows you to fire up a device that has the same Yang models as a real device, but it doesn't have anything else. And most of the time, it's basically just taking those Yang files and launching it up in NetSim, and that's it. But sometimes NED is doing a little bit more than that, so there could be work for the NED team in this too.
I have a quick question on the last one. So, the previous slide, so the HA. So, I mean, this talks about, if the configuration differs between the two, like routing engines or whatever, But if they're the same, some devices, the config is exactly the same, but it's just that you have two different IP addresses to reach the device, one per control plane thingy, right?
Yeah.
Is there any form of support in NCS for figuring this out, or do you have to write a service yourself to do that?
You can either do it in the service, but the NED could support it if they wanted to. And there's only one management address in the device list, but you could, of course, have a meta-level NED configuration for devices with some sort of behavior there so that you can switch over. You can solve this if you really wanted to.
Yeah, I do. I'm just curious. Since this is the first time I've seen this.
Yeah. But most of the time, I mean, one management IP address should be fine for most cases. So. And we have the documentation, of course. And sometimes people think that they should read the NED documentation instead of the device documentation, and that is rarely the case, right? We are not writing the manual for the device. We are just writing, how do I install my NED? How do I build it? What are the caveats? Is there something in particular that you need to think about? That's what's in the NED documentation. Okay. Yeah, all right. Say again? I mean, it's just playing YANG files inside the NED directory, so yes. It's under the source YANG directory inside the NED. So what are the functions that NSO is asking a NED to do? What are the tasks that it needs to implement? The first one is NSO might ask the NED to say, can you connect and authenticate towards this device, please? So then the NED needs to figure out, how do I log in? Do I use SSH or some HTTPS REST call, or what do I do? And how do I authenticate? Do I look for the username :prompt, or what do I do? Okay? And how do I supply a password and stuff, or crypto things? The next thing NSO might do is ask for the device capabilities. It will ask, okay, which YANG models do you support? That's maybe the most important. And also things like, do you support transactions? Do you have a candidate? Do you have, and all sorts of other things that they want to know. Can you do these sort of things or not? And for netconf devices, the device will respond happily with this list with YANG models and capabilities. But CLI devices, for example, would not. So then the NED will have to encode, hard code in most cases, an answer. These are the things I know this particular device can do. So it will say, yes, it can do transactions. It's an iOS XR device. We are talking CLI to it, but it's still transactional. So it supports transactions. Can it do candidate? Well, over CLI, it cannot. Okay. So you have a list of capabilities, and these are the list of YANG models that we know that this device has. And here's the answer. There may be some NEDs that support a family of devices. So you have the small, the medium, and the large has a few more capabilities, maybe more YANG models or something like this. So then the NED might need to go and probe something, show version or show whatever, feature or something, and then figure out, oh, this device actually has this thing, so it will report one more capability in the return. Make sense? Yes?
Does that extend to command sets? Like if you have a real network device with a real configuration, does that capability also say, hey, this is what I couldn't understand in the real device?
I mean, the NEDs could probe anything you like and then report the capabilities accordingly. But I think the strategy in many NEDs is to have a large set of YANG files that support everything that's in the family. And if you happen to have a device that is less capable than everything, things will fail later. You will try to send this command, the device will say, I don't understand what you're talking about, and the transaction will fail. To model all these individual differences in the NED would be hard work for us. We don't even know all the device family members and exactly what functionalities were. Next, and crucial, as you may remember from the presentation yesterday about performance, is one of the tasks NSO has for NED is, can you figure out, are we in sync? Check sync. And that can happen in a variety of different ways. Some of them are very fast and efficient, and some of them take much longer. It may connect to a device and check the transaction ID, if the device supports the transaction ID. So every time NSO commits a transaction, it will ask immediately, what is the transaction ID now? Save that, keep it a track, and then ask later, what's your transaction ID? If it compares the same, it knows, NSO knows that the device has not modified its configuration. So we are in sync. If it has changed, then okay, we have to work out what are the possible differences, and that's a heavier operation. But we can check quickly, ideally, if we are in sync or not. Many devices don't support a transaction ID, but they might have a timestamp of last change. That's also pretty useful, but that timestamp usually resets at the reboot. So sometimes we'll see a change where there actually has been no change and stuff like that. So it's not ideal either, but it may work. Some devices don't have anything useful at all. So then the only thing that we can use as a sort of, instead of a timestamp or ID, is that we do show running config, show it all, and then compute a CRC or some other checksum over that. And if you take that checksum and compare with now and later, you see it's exactly the same checksum. We're pretty sure that the config hasn't changed. But doing show running config on the device, it can take minutes. So that is not perfect. Yes?
So I guess the first one example would be iOS XR with the transaction ID.
Yeah, that one supports transaction IDs. That's nice.
iOS that would be depending on the box.
You can actually, I'll come to that. I think you have a slide on that. Yeah, you can configure, actually the next slide here. On iOS, you have a variety of choices. You can choose as an operator which mechanism NSO should use for this device. So the default option here is config hash, which is this show running config, and then calculate an MD5 sum of that. That's expensive, but it works always. And it's always correct, no matter if you reboot or anything like that. It just works. There is this last config change timestamp, but it will, if the device reboots, you will detect a change even though there is no change.
And it's not available on all iOS.
It's maybe not available on all machines either. So it's not terribly good for that. But if you know that it's supported on your device and you don't intend to reboot very often, and if that happens, you'll take the hit anyway. You can choose that one. There's this show configuration ID supported by certain devices, but that also changes at reboots. So it's not so useful either. And show configuration history, it's a little bit slower than showing the ID, and then you can look at the timestamps for all the latest transactions to see if something has happened.
When you say it's not useful, I mean, typically you don't reboot very often. So
No, yeah.
it doesn't break anything, right?
You will have false positives sometimes. If the device has rebooted, you will think that you're out of sync when you're not. Yeah. If you can live with that, that's a good choice for you. Yeah, so if you think that's acceptable to you in your factory, fine, choose that one, that's okay. For some other use cases, it may be terrible. Yeah, you can see, you can choose for this NED which particular method to use, and this will impact performance quite heavily. Another thing that NSO might ask a NED to do is commit a dry run. You may wonder, why is the NED involved at all in a dry run? What's going on here? This is exactly the case where we don't want to talk to the NED, right? Well, actually, you do want to talk to the NED in dry run sometimes, when you do an out format native. Because, I mean, these commands that we want to send to a CLI device, they are not computed by the NED. They're computed by NSO, by the transaction engine. So that the NED does not need to figure out how to sequence commands. It has already done this by providing a Yang model with annotations. This is how you format things. These three things on the same line. This one before this other thing. This is a submode. You can just say commands with a short. Yeah.
Why does it have to have reachability of the device for native?
Some NEDs do that, but I'll come to that. Yeah, the configuration commands are computed by NSO and not the NED. So in most cases, we just take this blob of text and send it to the device, right? It knows how to connect and log in and all of those things, and then you dump this text on it, and it does whatever it does. And then all the NED needs to do is try to look for, was there an error message somewhere along here? And but there are special handling sometimes. For example, commands that you know, ser and peer, and I don't know, all these sort of special commands that have strange behaviors. So even though the NED gets this big string blob, it may need to go in and alter a few things, like add an add or remove or something for the VLAN in that big string. And if you want to see, as an operator, do this commit dry run out format native and see what is actually going to be sent to the device. Not what we computed in NSO, but what will the NED actually push down. You have to ask the NED to do this, even including those add or remove VLAN tags. Obviously, one of the things the NED needs to do is to change the configuration, to push down. I mean, we talked about dry run now, but this is to actually go live with it. It also needs to retrieve operational state. Basically, show commands. being able to show all those counters or states or whatever it is. This is not computed by NSO, so this is often hard work for the NSO NED team. If you have a lot of things, a lot of leaves that you want to be able to show in NSO, they have to be coded by Java code typically. You're easy to send out a show command to the device, then you get back a large string with lots of text in that represent information that you have to parse for a variety of different family members in this device family, for a variety of versions over time, for a variety of use cases, I mean for network context where things might be, in certain contexts, it might look different in the output a little bit because something is missing, or there's DNS like this, or there's IPv6 time, or whatever. So this is really difficult. That's why CLI nets typically have fairly small amounts of operational data, because this parsing is not easy. I mean, this parsing would be hard to be done by the device team itself. If the XR team or the XE team or something did this, that would be hard for them, but it's much harder for people at the tail of side to try to figure out what might come out.
Do you have a general stance on this stuff? Because I've received tickets where the answer from you has been, no, we do not do this because this is too complicated. You will have to parse it yourself in your application code, which then makes me question, why am I buying NSO at all? Because the whole point is to get something that is structured data. Otherwise, I would just write everything myself. So,
Excellent point. Excellent point. I mean, we are providing NSO as an application building framework to make it easy for you to write applications, and then we say, well, this is up to you to figure that out. This is too hard for us. But it really shows the point here. It comes down to the bare metal, or the ground rock. This sort of behavior becomes business decisions. That's really where we end up. And for tail-left, we said, no, that's not the cost of this is higher than the business return. So we say no.
There are partners who do it.
Yeah.
Like Cisco XR and
Yeah.
XC for BGP status and with hardware for VPN consolidation.
Yeah. I mean,
right, but so I mean, I see this. So first of all, I agree. I own the Netcom client that we're working very hard. We're one of the guys working very hard to get there with all the vendors. But when you have to do this, I think the right way or the right place to do it is
in the net.
tail left, by tail left in the net, right? For me to do this doesn't make any sense.
Agreed.
You wanna aggregate the data you get from all your customers that need this kind of and put it in unit test, blah blah blah.
I couldn't agree more. It is exactly, we should have this functionality in the net, and if you find it missing, you should report it, and maybe we'll do it in the net. But what happens is that we have a net team of so many people. It's less than the people in this room now, but anyway, we have a team of people. They all work on something that somebody wants. So which one do we swap out for doing this? That's the business question we have to face. It's not ideal, but that's really where it comes down. It is a business decision in the end. It's terrible.
One business decision that was made with one of our customers is they've asked us to upgrade to the latest version, latest NEDs with this status so that they can push it back to you guys so that it's much easier for you guys to integrate it into your NEDs.
Yeah.
So it can be treated a little bit more like an open source thing. If we do it and our customer lets us push it to you, then you bring it into the NEDs, and as opposed to invent it at your shop if it's too time intensive.
Yeah, it may be. Yeah.
Do our own piece, right?
Yeah, it may be that we can source back code that was written in the net layer by somebody else, but it's also a potential problem because we then take both the business risk with maintaining that and who knows what the quality is. Yeah, and if we need to maintain it, we don't have the expertise on how things work there. We might easily break it without knowing. So it is not easy anywhere there. But it is a very good point that you're making. But this is the terror that has been plaguing this industry for 30 years now. We have been trying to manage devices by CLI, and this is what we end up with: mess. And people saying no to very very reasonable feature requests because of money issues. It's not a technical decision anymore. It's just about money. That is where we end up. A terrible place to be. But we have become used to this. We have been in this industry for 30 years already, and we know all the big dragons. We have all been here and done this. So. Another thing that a NED might be asked to do is to invoke an action on the device. That could be something like ping or clear the counters or whatever it is. This is usually fairly straightforward because actions are not that complicated. You just run a command, and whatever you get back is what you return or something. So. Some devices produce notifications, asynchronous notifications when something is happening that the NED needs to consume. This is not very often though, because most of these notifications, they come out in a channel that doesn't interest the NED. For example, it comes out as an MP traps or notifications, or it comes as a syslog messages or something like this. But sometimes it comes out as rests or something, rest calls or some sort of information that comes out from the device. Or in the case of netconf, of course, we have netconf notification support already, so that's sort of built into NSO. Not much need to be done here. Then, okay, so these are the calls that NSO is asking the NED to perform. But then, of course, it's up to the NED to do the back-end communication to translate all of this into the sort of lower layer protocol. In the CLI case, we get all of these big strings already, but we may have to tweak a little here and there for some reason. And we have to parse the result for prompts and error messages and stuff. And for REST or SOAP or TL1 or whatever, we have to compose valid sequences of valid messages, which is not always that easy. There is no SOAP message to set this thing that you just changed. The only SOAP message you can send is something that sets 6 things. So you need to read out those 5 first, add the changed one, and then push it back again. And then you need to verify that it's actually there. You need to do 2 other REST calls or SOAP calls or whatever to verify that things are up and running. Very irregular in many cases. Any comments or questions on that? I'll take a look at then what transactions mean for a NED. First, a little bit sidetrack with the theory for transactions here. Okay, so we are looking at network management where you have a manager and you have some workers. We like to think of the manager as the general. He's putting out orders to his workers, or his soldiers maybe, but I don't want to need some military. And he thought out that you should be 41, 42, 43, and the workers are doing 41, 42, but the third B came up with a better idea. He says, well, if you say 43, you really mean 43.3. But these orders, they have a seal that shows that it comes from the general and have not been modified in transit. So the worker is violating the worker's law if he changes his config to 43.3 when the general said 43. That's a really bad thing. He's pretending that the general said 43.3. If 43 is a bad idea, the worker should do one or two things. He can either reject the order, say, no, I can't do that. You're asking me to cross a bridge that doesn't exist anymore. You can't do that, sorry. I will rather tell you now than fail. Or he can choose to try. He will go to the bridge, wait there until it's reconstructed. He will go as far as he can and wait. And whenever the bridge comes there, he will cross it. So that's the sort of approach he can take. Either he's rejecting it, or he can try to do the thing. As soon as it's possible to do it, he will do it. But if he's choosing the second thing, he must not change the configuration in any way. Maybe he will go to 43.3 because that's the only viable point to be at, but he shouldn't pretend it was the general that said that. The general said 43, and he will try to implement the general's order by going to 43.3 because that's the best thing he can do. Maybe. But don't pretend it was the general's order. Don't change the order. You're not allowed to come up with your own translation of what the order said and change your own configuration. That's a transactional view of the world. Okay, so we are providing, and it's always providing a transactional API to the applications, right? But many or even most devices on the network are not transactional. So we need to do something in order to make devices in the network or the system appear transactional anyway. There are some problems with devices that are non-transactional that unfortunately shines through. Coming back to this, we want to offer this perfect model, but sometimes we don't know, at least not to a reasonable cost, how to make that happen. So there will be some warnings here about things that are shining through. Bad behaviors from the device that will actually affect the way that you write your service. Okay, we have transactions. They have an old, by now 30, 35 years old definition. Anything that is atomic, consistent, independent, and durable is a transaction. It doesn't even need to involve computers if you don't want to. But anything that fulfills these 4 criteria would be a transaction. And that's what we need to provide to our application clients. And when we got this transaction concept into the enterprise business world 30 years ago, suddenly there was an explosion of new applications and agility in the business world. Banks could merge and stuff like that. It could still work. And that's exactly what we want to do here. We want to replicate this boom by supplying transactions to the applications. But what it means, a transaction consists of, a simple transaction consists of 2 phases. It's a prepare phase and commit phase. Or in a more complicated case, I didn't show that here, that's prepare, commit, confirm. But if things can also go wrong, so it might be that we end up with prepare, abort. That's another option. If we don't go through with the transaction, we would prepare, abort. In the prepare phase, devices or participants in the transaction, they should just verify as far as they can whether they will be able to do this or not. Is this a good transaction? Will I be able to do it? So that's a validation. It should not be visible to the outside world that any transaction is going on at this stage. At prepare time, everything is just internal. We are just looking at this, considering it, can we do it? We are asking every participant, prepare, can you do this? Can you do this? Can you do this? Then we get the answer from everybody in prepare. Yes, yes, yes. If all participants say yes, they can do this, we proceed with commit. That's the point of no return. Okay, everybody said yes, it has happened. We publicly declare it is now official, this transaction happened. And then we tell all devices or all participants about it. Yeah, commit, commit, commit. You have already promised you can do this, so now let's do that. Since devices aren't transactional in reality in many cases, and they are not able to validate without activating a configuration. We can't ask an iOS device, here's the configuration, can you do this? The only response you get is, try me. You push the config on it, and you'll see what it responds. But by pushing the config on it, it has already changed behavior, and then thus violating the rule in prepare that it should not be observable from the outside. And if we decide, yes, yes, no, oh, we have to abort. We have to tell everybody, let's not do this. And if you have only prepared and validated and not touched anything, it's easy because you just drop things. Okay, forget this thing, we don't do it. But if you have in prepare already activated some new configs, you have to, well, roll back or something. You have to undo. We call it abort. We say we have to put back the original configuration on it. So that is what the NEDs are doing together with NSO. NSO is computing the diff for going forwards and backwards. And for non-transactional devices, we are actually pushing out the configuration change already in the prepare phase, somewhat violating the constraints of what a transaction should be. But that is the closest we can get with these devices. They still get either there or they don't, but we might have upset the configuration even if some participants rejected the configuration in the meantime. But this is what devices do. The consistency requirement in the transaction, among other things, says that a transaction happens instantaneously. It happens all at once, logically speaking at least. It's not this first, this later. This is all now. And if the device has any opinions about which sequence should be, how it should go from the current state to this new state in configuration, it needs to figure out that on its own. It's up to that device to implement this new state that you want to go to with instructions in a particular order if it wants. But real devices that aren't transactional, they are very picky usually about which order you send these commands. First you have to create the interface, then you can set the IP address. and or VRF and whatever. So yeah, the NEDs will have to figure out the sequencing of this. We have autoconfig. That is when the device is changing its own configuration. We said that's not a good idea. The general gives the order and you are not allowed to modify it. But devices do, in CLIs especially. So if I create a configuration A, the device might also create spontaneously configuration B. And of course, that is not great. We will not, assuming that NSO will compute configurations for this device going forward, it will not know that the device has configuration B already set. So it will be assuming the wrong thing about the state of the device. So when you are, what was this? Okay, you have a configuration like on the left, and then you set speed auto. So then auto happens to be default, so in the right side we don't see speed anymore because it's a default value, so that's okay. But duplex full also disappeared because speed auto, for some reason, also deletes duplex. We couldn't have known. So the thing that you need to do in NSO, this is one of those cases where it shines through to the service. The service needs to be aware of this, unfortunately. And what the service needs to do is to, every time it's changing duplex, changing speed, it will also have to delete duplex as part of the transaction, because then NSO will be in sync with the device. No, it's not, and it couldn't be. Because even if we hard-coded this deletion in the NED, any manager on top of NSO will still not, there's a stack of things on top of each other, and they would never know, so it will not percolate upwards. There's no mechanism for percolating things upwards. So instead, it's the device that should stop doing this. Failing that, the service needs to take it.
Yeah, but the nets can be made to do that. With the annotations, right?
The nets can be tweaked to do things like this, but what's the point? It's not solving the problem. Yes, I know. Say again? Exactly. So you have to take it at the lowest possible level then, and that happens to be the service now. That is the one that is deciding the orders. Unfortunately, I mean, we want to have this nice and clean programming model, but here's a shortcoming of the device that's shining through to the service. Another similar case is another change of configuration that the device is doing spontaneously. You know, you can configure, for example, DHCP values with either an integer from 0 to 63, or you can use AF41 and I know all sorts of other strange notations for them. So they have two different values that mean the same thing. So if you, in your service, configure, in this case it was the protocol number, 179 meaning BGP. So if you configure in your service an access control rule that says equals 179, when you show the configuration by the device later, it will say equals BGP. So it has modified the configuration. This is not what the general said. He said this. Somebody might know that this actually means that, but the NED and NSO does not. So we will constantly see that there is something amiss. When you compare the configuration with the device, you will see it's not the same. Something has been modified here. So in order to solve this, the service should use the canonical value directly. So the rule should say equals BGP. Then the problem goes away. Sorry for you. I don't know what we can do about that. It's the dirty CLI world again. Another thing that may affect applications is that the YANG models that we're creating in the NEDs, they're trying to cover a whole family of devices, and we don't know too much about what the device is actually doing, firewalling or routing or whatever it is. So we don't know exactly what all of these things that we model actually mean and how they can be used, and this one cannot be this value when this other thing has that value, and if this one is 40, then this one has to be less than that. All of those things we don't know. So the YANG models that we produce will be way too lax. There will be many configurations that you can configure according to the Yang that are not valid on the device. And we have no intention of trying to close that gap to make them very, very tight and precise so that you can validate exactly. Because that would be requiring on us a much larger understanding of the devices and raise the cost dramatically. The solution, as in all of these cases, is netconfig Yang from the device. So here are some cases. Maybe one NED is seeing that if you say MTU 20,000, it will say that is out of range because we happen to know that and we capture that requirement. But in another case here, that's duplex duplex half is invalid when you have speed auto. That's something that we didn't know and we didn't model. You will find it out soon enough anyway. But it's affecting the programming model for the device. You should have this in the Yang. We haven't. Okay, sorry. Another case here is Yang model surprise. In some cases, there are CLI commands that behave where you basically, they don't behave like show running config. If you take show running config, they would not contain some of the verbs that you would assume otherwise. For example, here with VLANs, you have to have this allowed VLAN add 1001, but when you show it, it will show VLAN or remove, and then the VLANs will be listed without this verb add or remove here. So those kind of action commands or macros cannot be supported in the Yang model because they are not part of a data model. They are a part of a protocol for modifying a configuration. So they cannot be modeled. This sort of behavior cannot be captured in the data model. So that's why in the Yang models, we have to model something that works as a data model, basically like the lower part here. But it still has to issue the add and remove commands when writing things to the device. So that's one of those cases where the NED actually needs to get this large string. Here's the config that you need, and actually compare with what's on the device. See, oh, it already has VLANs 1000 and 1001, but it's adding new 1002, so it needs to do VLAN add 1002 for that one.
But does it use that approach, or does it just remove everything and reconfigure it?
Depends on where you are. For VLANs here, actually, it's actually doing this. But for ACL rules, there is no way to change a rule in the middle, so you have to remove all the rules up to the point where the first change is and then push back new rules. So, but that's another thing. But this means that the Yang model might not look exactly like some people expected to, because they were expecting to see some add leaf or something like that, and they don't find it. So what do I do now? I want to add one, and how do I add it when there's no add leaf? But this is just a Yang model surprise. You don't need an add leaf. It's not part of a Yang, not part of a data model. So here's just an example of what it looks like. Switch port trunk allowed VLAN 1001. And what is actually, here you come to dry run out format native. What is actually pushed to the device is this. Switch port trunk allowed VLAN add 1001. So that was a word that was pushed in by the NED. And you can see it in dry run out format native. Louder, please.
If you do the switch port trunk allowed VLAN 1001 on the switch, then it removes all VLANs and only puts this one in. So now the way you put it on the switch and the way you put it in the function is actually different.
Yes, definitely. But this behavior that you had with add and remove, that is not possible to model as a data model. That is action command. It is not possible to get that into the data model. So we have to model it some differently. We could have first tried to to choose different naming so that it would be more obvious that this has nothing to do with the old syntax, you know. That would have been impossible. But it's not possible to have add and remove as part of the data model. That would be just wrong.
But if you want to remove one VLAN from that trunk, how would that look like?
There are commands in NSO to manipulate list, and you can use those. You can. I don't know if this is modeled as a leaf list or list, but you can know things out of a list in NSO, but it doesn't have to do with the Yang model. Sequencing. So, okay, I already talked about that several times, that devices, CLI devices especially, but even REST and other devices are often very picky about the sequence that you do things. You have to do this first and that later. And in a transaction, it's given to the NED as one unit. Here's all the things we want the config to be like. Make sure it happens. And it needs to split it up and send it in the right sequence. For CLI NEDs, they get this served by an NSO CLI computation engine. So they don't need to change anything there. And if this is, again, we want to have this nice programming model, but sometimes this sequencing is something that we know that we haven't figured out in the NED. Back to your point, of course this should be in the NED, but sometimes it isn't anyway. And sometimes it may even happen that if you point this out in a request, I think it's happened a couple of times that we say, no, we won't do it because we don't understand this thing. We don't know how it works. We can't do it. So you figure it out in your application. So this non-transactionality will occasionally shine through to the application. But we all agree that this should be in the NEDs. This is the NED task. NEDs should do this, should handle this. But sometimes we might not be able to deliver that anyway, at least not in a timely fashion. I have some more slides here, but I'll go a little bit faster because we are running out of time. The long-term remedy for all of these shortcomings, of course, we know that already. It's netconf and yang. That will fix these things. So that's the way that we want to work towards the future to remove issues, is to go that way. We have Netsim. So if you take on the picture on the left there, that's a traditional network element. It could be a router, a firewall, or it could be OpenStack or whatever. It has the management framework on top. It has some sort of database inside. It has a large chunk of the real software that's doing the interesting things. And then in the bottom, it has some sort of kernel and device drivers and who knows what else, right? That's a sort of picture of what a network element is like. Some of the network elements out there are running conft, which is an agent framework for building management frameworks in devices. And then you have Yang models in there. You have the CDB database. Otherwise, it's the same thing. But if you take one such conft-based network element and rip out the core software, kernel, device drivers, and all that, you get something like this. It's just a database and conft and some Yang models. That is a NetSim device. So we can fire up for any NED, more or less anyway. Almost every NED supports NetSim. So you can just fire up, I want to have a device that behaves from a management perspective just like one of these devices or those devices, be it a CLI device or netconf device or any other. We just fire up one of these, and it will, from a management perspective, behave much like the real device. It will have the same Yang models. It is also possible in a NetSim environment, and some devices have it, to push in a little bit of simulated software in here, so that it gets at least some of the core software behavior in here. Because I mean, this one, you can configure something to be 45, and it happily remembers 45, but it doesn't do anything else. It's not passing any packets, and it's not upping any counters or whatever. You can read things from it, and it will be all zeros mostly. But here, by pushing in this piece of simulated software into the NetSim environment, you can make it do some things. For example, the NetSim for the Elastic Services Control, the ESC, has something. The ESC is used to spin up virtual machines. So if you configure the ESC to spin up the ESC NetSim to spin up a virtual machine, the NetSim ESC will come back after a few seconds and say, it's done, it's there. So that you can use this NetSim in your environment to simulate an ESC and get past to the next stage. Any device, really. But for most devices, the communication to the NetSim will be netconf. But for CLI devices, you can specify, I want to use CLI commands, but they will, of course, be the conft CLI in that case. So NetSim is very useful. Let's say, for example, that the device that you're planning to use does not exist yet, because it hasn't, the team that is making it isn't done yet. There is just no device like this in the world. Or you want to do some prototyping and you're just imagining, what if we had a device that's doing this, and you want to prototype a larger scenario, you can make a NetSim model of something that doesn't exist yet. Or they may exist, but you don't have any. That's also a useful case. We bring in a NetSim. Or you don't have the 3 ones that you need for your use case. I have 1 real device, but I need a few more. Or actually, I need 3 for each developer. And we are 6 developers in this team. So I need 18 of these. Or you want to do a simulation or tests for scaling. I want to have 1,000 of these devices, and I could never afford that. So then you can use NetSim to simulate large numbers of these devices. Very useful. But remember that NetSim is only an approximation. It is running with the same Yang models, so in that sense, it's a true copy. But it does not really behave as a real device in every other way. For example, real devices, they tend to be the same, like if it's an iOS device, if you send some configurations that are valid by the Yang model, they will reject it, saying, hey, this is invalid, you can't have this and that at the same time. Stupid. But the Yang model doesn't say anything about that. It looks like it's valid in the Yang model. And the NetSim will happily accept it because the Yang model says this is fine. And there might be timing things, and it's also the case that sometimes you get a configuration that's actually working on the real device, but it's not doing what you thought it would. So it's very good if you can try the real use case with some real devices that's actually passing the package that you expected, because even if you get the config on the device as you thought, it's not doing exactly what you need. So advice when using NetSim, yes, use it. It's very efficient way to grow your development team into large numbers and test early. That's really good. But do also test with real hardware. Don't think that just because it works with NetSim, it's going to work on real hardware. So test early with real hardware, and then keep testing with hardware from time to time during the project. Just because it worked in the version that you had a month ago does not necessarily mean it keeps working now. We have this red whale that we've talked about. It's a project load diagram. It's very thin in the left, and then spikes up towards the end and peaks at the end of the project. That's not what we want. So to avoid the red whale, you need to do this sort of testing towards the beginning, or at least not late in the project. You start early with testing with real hardware to validate that your design is okay. Otherwise, you get this peak towards the end, the red whale. I often get questions around, okay, we have this NED XYZ. Is my use case supported on it? Or does it support VLAN, whatever, tagging, something? Okay, I have no idea. But how do you find out what is supported in this NED? I think one of the best ways is to load it up in NetSim, and then load the configs that you're interested in on that NetSim. If that works, well, those commands are supported in the Yang model. So that's the good way of finding out. And then probably not every command is there. You have some sort of banners, and you have some sort of crypto keys that might not be supported. They're not relevant for your use case anyway. So you comment them out and load again until then you see exactly, oh, actually, it was these 6 commands that were missing. So I'll report, I want a new version of NED with these 6 commands added. I had planned to show that to you, but we are out of time, so let's not do that then. Okay, this is just a summary. What do NEDs do? Well, what they don't do is they don't mimic the native CLI behavior exactly. So you can log in on a NetSim device and you get a CLI, but that will not be exactly like the CLI on the device. The Yang validation is not complete. You have these macros and action commands like add and remove. They will not be there. Yang NEDs have no ideas about what's the canonical value, so you better use the canonical value yourself, as we talked about. If you want to troubleshoot NED stuff, turn on log level. You can do this in Java VM, Java logging logger, and set level all, and set the device trace, my device trace raw. That will enable a maximum amount of logging what goes on towards the device. And that's what you need to attach to any reports that you send to NED team. This is what's not working. And also, please, describe what you're trying to do and describe what you were expecting that should happen. When you do this, we want this, because we are network dummies. We don't know what you want or how these devices work. So state clearly, it gave me this, but it should have done that. We don't know. And if you want a NED to be created or updated with additional functionality, we need to know the device model and version. We need to have access to a device, unless it's a common device in the Cisco lab already. We need the configuration that you want to be able to apply. And we want to have use cases where things are being added, removed, and updated as relevant in your use case. Because this is what we will add to our regression test suite. So being able to see exactly what you want to do with this is important, so that we can, otherwise there will be additional iteration. We'll get there in the end, but it will take a longer time before we can deliver what you need if this is not supplied. We don't care that much about user manuals for the device. They don't give us the sort of information that we need most of the time. So that's nice, send them if you have them, but don't spend a lot of time digging up the device manuals. Not that useful. And sometimes what is useful is if you can find the contact name that we can ask, what is this, how does this work, what is, there's somebody we can work with that knows the device pretty well. And finally, we have this Pioneer package. If you want to work with NetConfNet today, you should use this Pioneer package. Or at least it makes it more friendly for operators to work with the Pioneer package. And you can download YANG models directly from devices if they support that. And you can build, you can disable YANG models that they're not working properly or that NSO does not support properly. And then do this sync from operation all in 120 seconds if you're really lucky. You can also use Pioneer to explore the transactional capabilities. If you have a number of different configurations for a device, you can make Pioneer try them out in different combinations and see that everything is working properly. I would let you ask questions, but we are out of time, so I'll do that offline instead. So thank you very much.